Do 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 do. Hello and welcome to week 3 of online learning with Mr. Osberg. I know you miss my face, but hey, at least you get to hear my nice soothing voice whenever you want because I'm on YouTube. So what we're going to look at start of this week is we're going to look at states of matter in reactions. So when we have a reaction taking place, we should be able to indicate what state of matter all reactants and products are in. So does that mean they are solid? Are they liquid? Are they gas? Are they aqueous? What does aqueous even mean? That's what we're going to look at now. So, reactions in aqueous solution is what we're going to look at primarily, and I've already filled in a bunch of this stuff for you. So, aqueous solutions just means it is dissolved in water. So, we want to know, is a substance a solid, liquid, gas, or aqueous when it's mixed with water? Does it dissolve? So, easy thing first is if it's an element, it's nice and easy. It will remain in the same state as found on the periodic table. So you should have your colored periodic table. If it is colored in black, when I say it, if the element symbol is colored in black, then it is a solid. If it is colored in red, it's a gas. If it's colored in green, it's a liquid. And synthetic is blue. That just means it's made in a lab. We don't need to worry about that. So other than chlorine, which I'll talk about in a second, if whatever state you find that element in, if you put it in water, it stays in that state. So for example, if you take a look at iron, iron is solid. If you put solid iron in water, it remains solid. The only exception here is chlorine gas. Cl2 gas changes to aqueous, so it actually dissolves into the water. So you can see that reaction here, Cl2 gas plus H2O liquid. We're going to put it in liquid water. We have it turn into chlorine aqueous here plus water. The water doesn't change. The only other exception is group 1 metals react with water to form new compounds. So if you put lithium, which is a solid, into water, it'll actually violently react with the water and you'll no longer have lithium by itself. So you'll form new compounds, so we don't have to worry about what state lithium would be found in afterwards. If we were in class, I'd also give you a solubility chart for molecular compounds with some common molecular compounds. Since we're not, and I'm not giving you that, don't worry about it. Ionic compounds are the one we want to focus on in this video. So ionic compounds, we use the solubility chart found on the reverse side of your periodic table. And what we're going to say is all ionic compounds are solid before we mix them with water. So if you have your periodic table, flip it over. If you don't, this is the table and you can just print it off. This is directly from the reverse side of your periodic table. So the way that we use this is we find whatever ionic compound we're talking about on this table, and it's going to tell us whether it has high solubility, which means it dissolves quite a bit in water, and we would write its state as aqueous, or whether it has low solubility. So basically it dissolves very minimally in water, so we just will remain solid. So the way that we use this table is you can see at the top, these are a bunch of anions. So what we're going to do is we're going to look at the anion in the compound that we're given, find it here, and then we're going to match up the cation or the positive part here, and that will tell us whether we have high solubility or low solubility. So if we take a look at our first example, magnesium hydroxide. So we look at our anion hydroxide, OH, so that's right here. And then we figure out our cation, magnesium, does that fall in this or in this? So magnesium is a group 2, so it's not group 1 and it's not one of these ones listed. So magnesium oxide would fall right here because magnesium doesn't match up here. So what does this tell us? That most, or in our case, magnesium hydroxide, is going to have low solubility. So if we wanted to write the state for this, we would just write S for solid. If we look at lithium hydroxide, again, if we want to know the state, we look at the anion, the hydroxide, we go here. Lithium, though, is a group 1 metal, so that's right here. So guess what? If it's group 1 metal with hydroxide, it has high solubility and it's aqueous. So lithium hydroxide is aqueous. Take a look at two carbonate ones that we have here. We have calcium carbonate and sodium carbonate. So again, in both cases, we're going to look at the anion first, the carbonate. So that's right here. And then calcium carbonate. Well, calcium is a group 2 metal, so not group 1 or ammonium. So calcium carbonate is going to fall right here, CaCO3, which tells me that has low solubility, so calcium carbonate is soluble. Sodium carbonate, on the other hand, again, we look up carbonate, but sodium is a group 1 metal, so that means sodium carbonate is going to fit in here. And what does that tell me about the state? It has high solubility, or it will dissolve quite a bit, so we write its state as aqueous. Let's do one other example here. Oh, sorry, we're going to do... I have already done those ones, so we don't need those ones. Let's do one more example. So vanadium nitrate here. So again, we look at our anion, it's nitrate. Go back up to our table. Nitrate is right here. Anytime you get a nitrate, it's nice and easy because every ionic compound with nitrate in it has high solubility. So vanadium nitrate is going to be aqueous. Two tricks. Anything with nitrate in it will always be highly soluble. The other one is any compound containing a group 1 cation is also going to be highly soluble. You'll see here most group 1, most group 1, most, and all. Group 1s are all going to fall in here. So anything with a group 1 will also be highly soluble. So ionic compounds, look up the anion first on this table and then determine, does your cation put you here in high solubility or here with low solubility? If it's high solubility, you write the state as aqueous. If it's low solubility, you write the state as solid. One thing that we can tag on with this is if a single or double replacement takes place in water, which is very common what we're going to be looking at, and one of the products is a solid, so we look up on that table and we get a solid, we call it a precipitate. And you probably heard that in both grade 9 and grade 10 because a precipitate is a sign of a chemical change. And here we'll actually see why. So if we take a look at this, sodium carbonate plus barium nitrate, these are two ionic compounds. This is going to be a double replacement, so we're going to swap the positive ions, the cation for cation. So we switch those cations and we will get barium carbonate plus sodium nitrate. And again, make sure that these are the proper compounds. So now the only thing we're missing is their states and then balancing. So we want to know states, so BaCO3, so you'd look up carbonate on that chart on the last page. Barium is a group 2 metal. It says high solubility with group 1 or ammonium and low solubility with most, so barium falls in that most category. So this has low solubility, so we'll write this as a solid. And sodium nitrate, anything with a nitrate, also anything with a group 1 metal is going to be highly soluble, so this will be aqueous. Let's go ahead and balance this. In order to balance, we're just going to put a 2 there. Now, what we set up here is if one of the products is a solid, we call it a precipitate. Well, guess what? We have a solid here. So barium carbonate is referred to as a precipitate. That's going to be very important moving forward so that we can identify which of our products is a precipitate, if any of them. So, good luck.